Hello everyone, welcome to Aakruthi Mathematics Simple Mathematics Classes. I am Sudhir MK. In this class, I am going to explain about relations and functions. And this is Relations and Functions Class 4. In this class, I am going to explain about types of functions and problems related to it. Now first we see what is function. Every relation is not a function. A relation f from set A to set B is said to be a function if every element of set A are related with only one element of B, and it is denoted by f from A to B. Now we consider one example. Consider set A with elements 1, 2, 3 and set B with elements A, B, C. Now we consider 1 related with B and 2 related with A and 3 related with B. Now here every element of set A have unique relations. Therefore this relation is a function. So this relation is a function. Consider next example. Consider set A equal to 1, 2, 3 and set B containing only one element, that is A. And here we consider the relation 1 related with A, 2 related with A and 3 also related with A. Here also all the elements of set A have unique relations. So therefore this relation is also a function. So this relation is also a function. Consider next example. Set A with 1, 2, 3 and set B with A, B, C. Now consider 1 related with B and 2 related with B and 3 related with A and C. Now here 3 related with 2 elements, 3 related with A and C, this relation is not a function. Therefore this relation is not a function. So consider next example. Set A with 1, 2, 3, set B with A and B. Now here 1 related with A and 3 related with B. Now here all the elements of A are not related. So here 2 is not related with any element. Therefore this relation is also not a function. So this relation is not a function. Now consider one function. In a function f from A to B, the set A is called domain. Now here first set A 1, 2, 3. This is called as domain and set B is called codomain. So second set is here A, B, C. So this is called codomain and set of images are called range. Now here range means set of images. Now here A and C is only image and here set AC is the range. So therefore here domain is first set, that is 1, 2, 3 and codomain is second set, that is A, B, C, and range is only images, that is set A and C. Now we say definition of domain, codomain and range of a function. Let f from A to B be a function. Then the first set A is called domain and second set B is called as codomain and set of all images are called as range of the function. Next we study types of function. We consider this function. Now here 1 related with C, 2 related with B and 3 related with D. So since different elements have different images, this type of function is called as 1, 1. So here different elements have different images. So therefore this type of function is called as 1, 1. Now consider this function. Now here 1 related with C, 2 related with A and 3 related with C. Now here different elements have same image. Since different elements have same image, this type of function is called as many one function. Different elements have different image. So therefore this is called as 1, 1. Now here different elements have same image. So therefore this function is called as many one function. Now we see definition of 1, 1 function. 1, 1 function is also called as injective function. So 1, 1 function is also called as injective function. Function f from A to B is called 1, 1 function if the images of different elements are different. So if different elements have different images, then that function is called as 1, 1. Now how to verify given function is 1, 1 in the given problem? Now consider a function f from A to B. A function f from A to B is 1, 1 function if for every element x1, x2 belongs to A, if f of x1 equal to f of x2 implies x1 equal to x2. Suppose if f of x1 equal to f of x2, then x1 equal to x2. If images are same, then its pre-images also same. f of x1 equal to f of x2 implies x1 equal to x2. In problems, we prove function is 1, 1 in this method. So next we consider one example. Consider one function f from n to r defined by f of x equal to 2x plus 3. Now to prove f of x is 1, 1, we consider f of x1 equal to f of x2, where x1, x2 belongs to n. Now here x1 and x2 belongs to first set. Now here first set is n, natural number set. Now here it is given f of x is 2x plus 1. So therefore f of x1 is 2x1 plus 3 and f of x2 is 2x2 plus 3. Now here f of x1 equal to f of x2 implies 2x1 plus 3 equal to 2x2 plus 3. Now we can cancel 3, 3 and we can write 2x1 equal to 2x2 and we can cancel 2, 2 and we can write x1 equal to x2. We started with f of x1 equal to f of x2 and here we are getting x1 equal to x2. So since x1 equal to x2, f of x is 1, 1. So next we see diagrammatic representation. Given f of x is 2x plus 3 and first set is natural number set and second set is real number set. Now here relation is f of x is 2x plus 3. When x equal to 1 we get f of 1 is 2 into 1 plus 3, that is 5. So 1 related with 5. When x equal to 2 we get 2 into 2 4, 4 plus 3 is 7. 2 related with 7. When x equal to 3, that is 3 into 2 6, 6 plus 3 is 9. That is different elements have different images. So therefore this function is 1 1. So next it is example 2. Consider a function f from R to R defined by f of x equal to 2x square plus 3. We check whether this function is 1 1 or not. Now we take f of x1 equal to f of x2. x1 comma x2 belongs to R. That is first set here real numbers. Now here it is given f of x equal to 2x square plus 3. Therefore f of x1 equal to 2x1 square plus 3. And f of x2 is 2x2 square plus 3. Therefore 2x1 square plus 3 equal to 2x2 square plus 3. Now here we can cancel 3 and we can write 2x1 square equal to 2x2 square. And we can cancel 2 and we can write x1 square equal to x2 square. And here we can write x1 equal to plus or minus x2. Now here x1 equal to x2 or x1 equal to minus x2. Both are possible. Now we started with f of x1 equal to f of x2, but we are getting x1 equal to x2 or x1 equal to minus x2. So therefore this function is not 1 1. We study diagrammatic representation of this function. We consider first set is set of real numbers, second set is also real numbers. Now we consider some relation when x equal to minus 2. It is minus 2 square is 4, 4 into 2 8, 8 plus 3 is 11. Also f of 2. When x equal to 2, 2 square is 4, 4 into 2 is 8, 8 plus 3 is 11. That is minus 2 and 2 related with 11 only. So therefore different elements have same image. So therefore this type of function is not 1 1. So this function is not 1 1. So next it is many one function. A function f from a to b is called many one function if different elements of domain have same image. If a function is not 1 1, then it is called as many one function. That is different elements have same image. Then it is called as many one function. Again we see diagrammatic representation. Now here we see different elements have different images. So therefore this function is 1 1. Now here different elements have same image. So therefore this is not 1 1 and it is many one function. So since different elements have same image, this function is many one. Now we consider this function. Now here 1 related with A, 2 related with B and 3 is also related with A. Now we consider second set. All the elements of second set are images. Whereas in this function 1 related with C, 2 related with A and 3 related with C. Now here all the elements of codomain are not images. Here all the elements of codomain are images. Here all the elements of codomain are not images. This type of function it is called as onto function. If it is not onto function, then it is called as into function. Now here all the elements of codomain are images, then it is called as onto function. If all the elements of codomain are not images, then it is called as into function. Now we see definition of onto function. Onto function is also called as surjective function. So onto function is also called as surjective function. A function f from a to b is called onto function if all the elements of codomain are the images. If all the elements of codomain are images, then that function is called as onto function. In onto function, range and domain are same. Now here all the elements of codomain are images, therefore range and codomain are same in onto function. Now we see how to verify the given problem is onto function. A function f from a to b is onto function if for every element y belongs to b, there exists an element x in a such that f of x equal to y. We have to take any element y belongs to b. We have to verify whether its pre-image exists or not. Therefore, we have to find one element x belongs to a such that f of x equal to y. So x is pre-image of y. If x belongs to a, then given function is onto function, or else it is not onto function. We consider some example. First example, consider a function f from R to R defined by f of x equal to 2x. Now here function is from real number to real number. To prove f of x is onto, take f of x equal to y and y belongs to R. Now here we take y equal to 2x. That implies x equal to y by 2. Now y by 2 is also real number. So therefore x equal to y by 2 and y by 2 belongs to R. Therefore for every element pre-image exists. So therefore this function is onto function. So therefore f of x is onto. Now we see diagrammatic representation of this function. We consider f of x equal to 2x and first set is real numbers and second set is also real numbers. Now we consider some relation. Now here when x equal to minus 1, f of minus 1 is 2 into minus 1, that is minus 2. And f of 0 is 0. And f of 1 is 2. And f of 1 by 2. F of 1 by 2 is 1. And f of 2 is 4. Now you consider any element here, all these elements are images. So therefore this function is onto function. So this function is onto function or it is surjective. Next, one more example. Consider a function f from n to n defined by f of x equal to 2x. Now you have to verify whether it is onto function. To verify this is onto function, take f of x equal to y and y belongs to n. Now y belongs to second set here. Second set is natural number set. Now here it is given f of x equal to 2x. Therefore y equal to 2x. So f of x equal to y. Therefore y equal to 2x. And we solve for x. So x equal to y by 2. but y by 2 is not a natural number. So therefore this function is not onto. So y by 2 is not a natural number. Therefore this function is not onto function. We see a diagrammatic representation of this function given f of x equal to 2x, and first set is natural number set, second set is also natural number set. Suppose you consider x equal to 1. When x equal to 1, 2 into 1 is 2. So that is f of 1 is 2, and f of 2, 2 into 2 is 4. That is f of 2 is 4. When x equal to 3, f of 3 is 2 into 3, it is 6. Now see here, all the elements of codomain are not images. So 1, 3, 5, all these are not images. So therefore this function is not onto function. So this function is not onto. A function f from a to b is onto function if and only if range of f equal to codomain. If a function f from a to b is onto, then codomain and range are same. So next we see what is into function. A function f from a to b is called into function if all the elements of codomain are not the images. If a function is not onto, then it is called as into function. Here all the elements of codomain are not the images. Now in this example, all the elements of codomain are the images. So therefore this function is onto function. Now here all the elements of codomain are not the images. Therefore this is not onto, and this type of function is called as into function, and this function is into function. Now consider this function. Now here different elements have different images. So therefore this function is 1, 1. And here all the elements of codomain are images. So therefore this is both 1, 1 and onto. This function is both 1, 1 and onto. So this type of function is called as bijective function. A function which is both 1, 1 and onto. It is called as bijective function. Now see here, when function is bijective, total number of elements in set A and total number of elements in set B should be equal. So here number of elements is 3, here also number of elements is 3. So when function is bijective, number of elements in first set and second set should be equal. Now we say definition of bijective function. A function f from a to b is called bijective function if it is both 1, 1, that is injective, and onto, that is surjective. A function which is injective and surjective is called as bijective function. A function which is both 1, 1 and onto is called as bijective function. So next some note. A function f from a to b is bijective function, then n of a equal to n of b. If a function is bijective, then total number of elements in set A and total number of elements in set B is same. Next we discuss some problems. So these problems are from exercise 1.2. First problem, show that the function f from n to n given by f of x equal to 2x is 1, 1 but not onto. So you have to prove that function is 1, 1 but it is not onto function. Now first we prove function is 1, 1. Now here it is given f of x equal to 2x, and we take f of x1 equal to f of x2, and x1, x2 belongs to first set, that is natural number set. Now here we can write f of x1 equal to 2x1 and f of x2 is 2x2, and we can cancel 2, we get x1 equal to x2. Since we started with f of x1 equal to x2 and we get x1 equal to x2, this function is 1, 1. Here function is 1, 1 function. So next we check whether function is onto. We take f of x equal to y and y belongs to n. So here f of x equal to 2x, so therefore 2x equal to y, and we solve for x, so x equal to y by 2, but y by 2 does not belong to natural numbers. So suppose you consider y equal to 1, then we get x equal to 1 by 2, so 1 by 2 does not belong to n, so therefore this function is not onto. Therefore f of x is not onto function. So this function is 1, 1 but it is not onto. So next problem, show that the function f from R to R given by f of x equal to 2x is 1, 1 and onto. Now here function is from real number to real number. You have to prove this function is both 1, 1 and onto. Now first we prove function is 1, 1. So here given f of x equal to 2x and we take f of x1 equal to f of x2, where x1, x2 belongs to R. And we can write 2x1 equal to 2x2, and we can cancel 2, we get x1 equal to x2. We started with f of x1 equal to f of x2 and we get x1 equal to x2. Therefore this function is 1, 1. Therefore this function is 1, 1 function. So next we verify function is onto. We take f of x equal to y, where y belongs to R. Now f of x is 2x, so therefore we can write 2x equal to y. Therefore x equal to y by 2. Now y by 2 is real number, so therefore x equal to y by 2 belongs to R. So therefore this function is onto. Therefore this function is onto function. This function is 1, 1 and onto function when it is a function from real number to real number. So next problem, show that the function f from n to n given by f of 1 equal to f of 2 equal to 1 and f of x equal to x minus 1 for every x greater than 2 is onto but not 1, 1. You have to prove this function is not 1, 1 but it is onto. Now first it is 1, 1 function. Here it is given f of 1 equal to f of 2, but here 1 and 2 are not equal. Since it is of the form f of x1 equal to f of x2, but here x1 is not equal to x2, 1 is not equal to 2, therefore this function is not 1, 1. So therefore this function is not 1, 1. Next we prove that this function is onto function. Now here we take f of x equal to y and y belongs to n. Now here f of x is x minus 1. So x minus 1 equal to y and we solve for x. So x equal to y plus 1. And y plus 1 is natural number. You take any element for that pre-image exists. So therefore this function is onto. Now here all the elements of codomain are images. So therefore this function is onto. So therefore this function is not 1 1 but it is onto. So next problem, show that the function f from r star to r star defined by f of x equal to 1 by x is 1 1 and onto, where r star is the set of all non-zero real numbers. Is the result true if the domain is replaced by n with the codomain is being same as r star? So here r star means set of real numbers without 0, and here function f of x is 1 by x. You have to show that this function is 1 1 and onto. Now first one, it is 1 1 function. Now here it is given f of x is 1 by x. So here f of x is 1 by x. And we take f of x1 equal to f of x2, where x1, x2 belongs to r star. Here x1 and x2 are non-zero reals. Since f of x is 1 by x, f of x1 is 1 by x1 and f of x2 is 1 by x2. So therefore 1 by x1 equal to 1 by x2. From this we can write x1 equal to x2. Since f of x1 equal to f of x2 implies x1 equal to x2, this function is 1 1 function. So this function is 1 1 function. So here f of x is 1 1 function. Next we prove it is onto function. We take f of x equal to y, where y belongs to r star. Now f of x equal to 1 by x, so therefore 1 by x equal to y. And here we can write x equal to 1 by y. And here x equal to 1 by y, again 1 by y belongs to r star. Since y is not equal to 0, 1 by y is also real numbers. Therefore here every element of P image. Therefore this function is onto function. So therefore f of x is onto function. If you replace domain by n, then function is 1 1 function, but it is not onto function. So this function is 1 1 when domain is n, but it is not onto. So since pre-image of 2 is 1 by 2, it is not a natural number. So this function is not onto. So next problem, check the injectivity and surjectivity of the following functions. First one, f from n to n given by f of x equal to x square. Second one, f from z to z given by f of x equal to x square. Third one, f from r to r given by f of x equal to x square. Fourth one, f from n to n given by f of x equal to x cube. Fifth one, f from z to z given by f of x equal to x cube. You have to check whether these functions are 1 1 and onto. Now first one, f from n to n given by f of x equal to x square. Now here f of x equal to x square, we prove it is 1 1. Now take f of x1 equal to f of x2, where x1, x2 belongs to n. Now here f of x is x square, therefore f of x1 equal to x1 square and f of x2 is x2 square. And we can write x1 square equal to x2 square. That implies x1 equal to plus or minus x2. But here important, x1 and x2 belongs to natural numbers. So therefore x1 equal to minus x2 is not possible. So therefore we get x1 equal to x2 only. Now since x1 and x2 belongs to n, x1 equal to minus x2 is not possible. So therefore x1 equal to x2. Therefore this function is 1 1. So this function is 1 1 function. So next we verify whether it is onto. We take f of x equal to y. Y belongs to n, and here it is f of x equal to x square, therefore x square equal to y. This implies x equal to root y, which is not a natural number. Suppose if we take y equal to 2, then root 2. Root 2 is not a natural number, so therefore this function is not onto. So this function is not onto function. The next problem, f from z to z given by f of x equal to x square. Now here it is given f of x equal to x square. We verify whether it is 1 1. We take f of x1 equal to f of x2, where x1, x2 belongs to z. So here x1, x2 belongs to z. Here it is given f of x equal to x square, therefore f of x1 equal to x1 square and f of x2 is x2 square. So therefore we can write x1 square equal to x2 square. Now here also we get x1 equal to plus or minus x2. Now since x1 and x2 belongs to z, we get x1 equal to x2 or x1 equal to minus x2. Both are possible. So therefore this function is not 1 1. Since x1 equal to plus or minus x2, this function is not 1 1. Next we verify whether it is onto. Now here we take f of x equal to y, where y belongs to z. Now f of x equal to x square. So therefore x square equal to y implies x equal to root y. And root y does not belong to z. Suppose if we take y equal to 2, root 2 is not an integer. Therefore this function is not onto. So f of x is not onto. Next problem. So it is given f from r to r given by f of x equal to x square. Now here it is f of x equal to x square. To verify whether it is 1 1, we take f of x1 equal to f of x2, where x1, x2 belongs to r. Now here given f of x equal to x square, therefore f of x1 equal to x1 square and f of x2 is x2 square. And we can write x1 equal to plus or minus x2. So here also x1 equal to plus or minus x2. Therefore this function is not 1 1 function. So this function is not 1 1 function since x1 equal to plus or minus x2. Next we verify whether it is onto. So here f of x equal to y. Since f of x equal to x square, we can write x square equal to y. This implies x equal to root y. Again, root y does not belong to R. If y is any negative number, then root of negative number does not belong to R. Suppose if we consider y equal to minus 1, root of minus 1 does not belong to R. So therefore, this function is not onto. So therefore, this function is not onto function. So next problem, f from n to n given by f of x equal to x cube. We verify whether it is 1 function. Now here we take f of x1 equal to f of x2, x1 comma x2 belongs to n. Now here f of x equal to x cube, therefore f of x1 is x1 cube and f of x2 is x2 cube. Now here directly we can write x1 equal to x2. So since f of x1 equal to f of x2 implies x1 equal to x2, this function is 1 So therefore this function is 1 function. Next we verify whether it is onto function. We take f of x equal to y, where y belongs to n. Since f of x is x cube, we can write x cube equal to y. So therefore, x equal to cube root of y is not a natural number. Therefore, cube root of y does not belong to n. You take y equal to 2, then cube root of 2 is not a natural number. So therefore, this function is not onto function. Therefore, this function is 1, but it is not onto function. Next one, f from z to z, given by f of x equal to x cube. First, we take whether it is 1. Here it is given f of x equal to x cube, and we take f of x1 equal to f of x2, where x1 comma x2 belongs to z. Now here f of x equal to x cube, therefore f of x1 equal to x1 cube, and f of x2 is x2 cube. So we can write x1 cube equal to x2 cube, and this implies x1 equal to x2. So since f of x1 equal to f of x2 implies x1 equal to x2, this function is 1. So f of x is 1 function. So next we verify whether it is onto function. Now we take f of x equal to y, where y belongs to z, and here it is given f of x equal to x cube, so we can write x cube equal to y. So therefore x equal to cube root of y, but cube root of y is not an integer. Therefore cube root of y does not. If you take y equal to 2, cube root of 2 is not an integer. Cube root of 2 is not an integer. Therefore this function is not onto function. So therefore f of x is not onto function. That's all in this video. I will continue this chapter explanation in next video. Thank you for watching. Please like, share and subscribe the channel for more video notification. Subscribe my YouTube channel, Aakruthi Mathematics Classes. Thank you once again.